Hi, welcome to our last lesson of Chapter 1. This is Section 1.7, Solve Linear Quadratic Systems. Our success criteria. Solve problems involving the intersection of a linear function and a quadratic function, both graphically and algebraically. So in previous math classes, you've solved linear systems where you had two linear functions, and now we're going to do one where we have a linear function and a quadratic function. And we'll solve this both graphically and algebraically. Okay, consider these two identical tanks, cylindrical tanks. So tank A is being filled at a rate of 10 liters per minute. Okay, so 10 liters are added every minute. At the same time, tank B is drained at an initial rate of 10 liters per minute out of the bottom valve. So there's a valve at the bottom of this cylindrical tank, and once it's opened, it initially drains at 10 liters per minute out of the bottom. So when will their water levels be the same? So what this is asking is it's basically asking you to think about a linear quadratic system. So the water levels rise at a constant rate in tank A, and the water level drops at a decreasing rate in tank B. So the one tank fills up at a linear rate, we could say, and the other tank drains at a quadratic rate. So if I were to look at a quick little graph of this, showing the amount in the tank versus time, the one would fill up linearly and the other tank would drain. And initially, the water levels drop really quickly, but as a tank loses water, it loses pressure and it drains slower and slower. So there's that one moment in time where this linear quadratic system has an intersection point, and that would be our solution. At this time, we would know they both had the same amount. So this is one application of solving a linear quadratic system. So what is a linear quadratic system? It's simply when we have a linear function and a quadratic function, and we're trying to find their points of intersection. Let's go ahead and take a look at this in Desmos. Okay, so here we have in the green equation, we have a nice quadratic function, x squared plus 2x. And then we have our linear equation, y equals 2x plus b. Okay, and I'd made the y-intercept b for the linear equation. I made it a parameter b because I want to use it as a slider. So right now we can see there are two nice solutions to this linear quadratic system, but as I change b, those solutions are going to change. So I'm just going to hit play and I'm going to let this animate. So we can see as the y-intercept changes from -10 to 10, our solutions change. We can actually see sometimes where there's two solutions and where there's no solutions. There's also uh, the rare case where we just get one solution. Okay, so it's a little bit hard to do this on Desmos here, but let's maybe if I make this 0, yeah, 0 looks like we might have one solution, exactly one solution for the quadratic and the linear function. Okay, so we can see depending on the y-intercept for this line, we may or may not have any solution. So this is an example of a linear quadratic system, and yes, the quadratics can change. They can also open down, and then we, have a new system that we can try to solve for. We can also change the slope of the line, and depending on our scenario, we may or may not have any solutions, or we may just have one solution. Okay, let's go back to the PowerPoint. So to solve a linear system, a linear quadratic system algebraically, and that means to find the points of intersection. What we need to do is follow some steps. Okay, so I've listed these out. So it says equate both equations. So you're going to have two equations. You're going to have a linear equation that's going to be in the form of mx plus b, most likely. And then you're going to have a quadratic form in standard form. Okay, what we're told to do here is we're told to equate them. So take the two equations and then equate them. Having done that, we can then bring all the terms to one side so that everything equals 0. And then solve the quadratic by factoring using quadratic formula or by graphing. Okay. And which is kind of nice, we've actually been practicing these here over the last few lessons. So once we solve it, we'll sub our x values, the solutions, into the simpler equation to get the y values. So when we do this step here, we're going to get some numbers for x. And then what we can do is we can plug them into the linear equation. That's usually the simpler one, and we can quickly get the y values that correspond to that. That's going to help us get the ordered pairs, the solutions, the points of intersection. After you've done that, you can then check your solution. You can take those points and you can plug them into the other equation. And you can see that those points satisfy that equation as well. Okay, if it doesn't, then you'll just need to go back and look for maybe any mistakes that were made. All right, let's go ahead. Let's try one. So we're given this quadratic equation and this linear equation. So our first step is to equate them. So we just take the quadratic and we set it equal to the linear equation. It doesn't matter which one you write first, as long as you just equate them. Then bring everything over to one side. Okay, so to do that, we would subtract a 2x on both sides, and then we would add 5 to both sides. All right, so now we can collect any like terms we have. So these are like terms, and these are like terms. So negative 7x minus 2x is negative 9x, and 15 plus 5 is 20. So we now have this nice, good looking quadratic right here. So we can solve this any way we wish to choose. So we could do quadratic formula, we could factor, we could solve by completing a square, we could even graph, okay? So most of these are going to work out nicely. We'll be able to solve by factoring. So that's what we're going to do here, because I can see that I have factors of 20, negative 5, and negative 4 that add up to negative 9. So we'll write that in factored form, x minus 5 times x minus 9. And now the nice thing is that these factors are set to equal 0. So the only way this line is true is if either one of them equals 0. So this needs to equal 0 and this needs to equal 0. So for x minus 5 to equal 0, x should equal 5. That's my first solution. And for x minus 4 to equal 0, x should equal 4. So I have those two solutions. Now what we need to do is we need to take those values for x and we got to sub them into the linear equation. Okay, I always pick the easier one. So subbing 5 in for x, we have 2 times 5 minus 5. That's 10 minus 5, which gives us just 5. So therefore, we have the point 5, as our first intersection point. Now subbing 4 in, 2 times 4 is 8. 8 minus 5 is 3. So therefore, we have the point 4, 3. So those are my 2 points of intersection for this quadratic linear system. I'm going to go ahead and check this by graphing. So let's go back, and I will bring up Desmos. Okay, we'll just plug in our 2 equations. We have x squared minus 7x plus 15. And then we have our linear equation, 2x minus 5. Okay, I'm just going to zoom in here now. Okay, so there's our two equations, and there's our two intersection points, 4, 3, and 5, 5. All right, let's move on to the next slide. So how many times will these two equations intersect? So we're not talking about the ones we just did, we're talking about these new ones. So the quadratic equation, negative 2x squared plus x minus 3, and y equals negative x minus 2. So to find how many times it will intersect, okay, we're not actually looking for the points of intersection, we just want to know how many times they intersect. So we kind of follow a similar process. We first equate them, and then bring everything over to one side, and then collect like terms. Okay, we now have a new quadratic. So instead of solving for the solutions to this quadratic, all I'm going to do is use what I know about the discriminant. As soon as this opens up, there we go. Use the discriminant b squared minus 4ac to find the number of solutions. So remember when we were solving quadratic equations, and if we were to use the quadratic formula, we had the discriminant inside of it, and the discriminant is underneath the root. So this part dictates how many solutions there are going to be based on the sign of b squared minus 4ac. Let's go ahead and calculate the discriminant for this one. So our b value is 2. This is the b value. And it looks like we have b here, and then we have a is negative 2, there's a, and then c is negative 1. Okay, so we just calculated the discriminant. We get 2 squared is 4, and then negative 4 times negative 2 times negative 1 is negative 8. This gives us negative 4. So since our discriminant is less than 0, that means no solutions exist. Okay, the discriminant cannot be negative. Okay, so if there's no solutions, then we know that these don't intersect at all. Now, if the discriminant is equal to 0, then there's only one solution. And if our discriminant happens to be greater than 0, then there's going to be two solutions. And when I say solutions, I'm actually referring to the points of intersection. Okay. All right, so that is it. We have a couple more examples we're going to do in the next lesson, so we'll see you there.